okay, all these are going to be sequences. In sequences, students think, oh, that's for higher level students. No, there are simple sequences that are part of the admission process for a kindergarten. So they don't have to be numerical, for example. They can be pattern-wise. So they can be red, red, blue, red, red, blue. That's what goes next. Red, and then blue, right? That's the pattern, right? And then you can make it numerical. 1, 2, 3, 1, 2, 3, 1, 2, 3, right? So I would put next. So they can be as simple or as complicated. They can be visual, like these three, or they can actually be numerical, like the rest of them that you have here. So in these, again, see, doesn't this look familiar? Yes, because these are the triangular numbers, right? Remember we saw a whole activity on the logs? So you are going to see that that first one, it is triangles, right? And then the student is expected to draw the pattern for the next three and then also quantify what is in there. For the second one, again, this is a different modality. It starts with 2, and then to that 2, they added one column of 3. And then to those 5, they added another column of 3. And what do you see? They keep adding a column of 3. They keep adding a column of 3 to the previous term. So basically, they are increasing by 3 each time, right? And then on this one is a little different. This one is started with 2. And the way that I see it, because I have students see it in different ways, the way that I see it, I take the 2 previous ones. See, I had 2. And then I kind of see like an L shape sideways. See right here? So they added 1 row of 3 and 1 column of 2 to the previous term. And then they take this whole thing, see right here? And they added 1 column of 4 and 1 row of 4 and 1 column of 3. And over here, they took the previous one and they added 1 row of 5 and 1 column of 4. And then in this one, they took the previous one, they added 1 column of 6 and 1 row of 6 and 1 column of 5, right? So as you see, it keeps increasing. They take the previous one and they add 1 row with 1 more than what they had. See, this one they had 4, now they added 5. This one they have 5, now they added 6. See? So the number of columns is going to be 1 more than what they had, right? Previously, and then the rows, right, which is an additional column in there, has 1 less than the number of columns in there, right? So you have that little pattern right there. And then for these, right, so we see that we have some arithmetic. Arithmetic, remember, means that you're adding the same constant, adding or subtracting the same constant pattern. Geometric is you're multiplying by the same ratio, multiplying or dividing by the same ratio. So in here, see, I'm adding 3, I'm adding 3, I'm adding 3. So the next one will be 14, 17, 20, 23, 26. And I give you that extra 129 so you know that you're going in the right pattern. On this one, they don't add the same number. So it is not arithmetic. Arithmetic is only when you add the same constant number. It is adding, but it's not going to be arithmetic. So this one, you're going to have, first you add 3, then you add 5, then you add 7, then you add 9. So what are you doing? You're adding the next odd number, right, to the previous term. The next odd number to the previous term. The next odd number to the previous term. And then on 6, I'm adding the next whole number, right? So plus 2, plus 3, plus 4, plus 5, plus 6, plus 7, plus 8, plus 9, plus 10. And I give you 1 there so you can verify that you're doing it right. Now 7, they are dividing by 3 or multiplying by 1/3. So multiplying by 1/3 is the same thing as dividing by 3. So if you divide by 3, you get 243. Divide by 3, you get 1. Divide by 3, you get 29. Divide by 3, you get 9. Divide by 3, you get 3. Divided by 3, okay. That's a fraction. So then you want to be able to change to multiplication by 1/3. And then multiplication by 1/3 and multiplication by 1/3, right? And then on what number is this? So number 8, right? So number 8, it is geometric because you're multiplying by 2 the previous term, right? Multiplying by 2 the previous term. And then 9 is, 9 basically is what we call, you have an activity of this, is what we call the Fibonacci rabbits. Remember the Fibonacci rabbits? So basically they start generating, adding the 2 previous terms to get the next term in the sequence. See? 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 21, 21 plus 13 is 34, and so on. So you're adding the 2 previous term to get the next one. That one is called the Fibonacci sequence. And then on this one, see, this is like one that your elementary kids will get really fast. 3, 4, 3, 4, 5, 3, 4, 5, 6, 3, 4, 5, 6, 7. So you're adding 1 more at the end of that little pattern, right? So adding the next whole number at the end of that little pattern. And this one is arithmetic because you're subtracting the same number over and over, right? So it is, which is 7. Now it says which one of these problems are related. So 2 and 4 are exactly the same problem, and 1 and 6 are exactly the same problem. Now, what is the difference? The difference is the one is in the diagram and the other one is not, and not as simply as a numerical one. And then what is the relationship between 1 and 3? So as you see, and I tried to put it in here because that's what they ask you on part B. The number of triangles on problem 1 is half of the number of squares in problem 3. And how can you rearrange the triangles? So you can see it by, see, just putting 1. And then you see I'm accumulating like everything to the right. And that way I can see like it's half of it. See, half, half. So you can see that they're half of the triangles are part of the squares. Then we have another one that it's called, right? So basically finding the rules. So we're going to call n just for the purpose of writing the rule, right? What is the rule if you need to determine the term? So what is the rule? So for this one, right, for this first one that I did for you, right? So you have n, and then it says each term number is 5 times the term number plus 3. So it's 5n plus 3, right? That's what it means. And then basically you're substituting the term for n, like 1 for the first position. 1, 5 times 1 is 5 plus 3 is 8. And that's a sequence number. Term number, sequence number, term number, sequence number, right? And this is a sequence. This is what you will see in the sequence, right? And the same thing you need to do for all of these right here. 4 times the term number plus 2, so 4n plus 2, right? And you find the sequence. What you do need to watch out is when you have the word subtracting from or less than. See right here? You have less than and you have subtracted from. So less than, whatever goes in front of the less, you write last. And whatever comes after the than, you write first. See, 5 less than what? 3 times the term number. So you're going to put 3n minus 5. And then, of course, you substitute the term number to find the sequence number. And this one, it says the term number times negative 2. So this is kind of a straightforward one. Plus 36. And on 5, it says 2 times the square of the term number plus 5. So you're going to square the term number, and then you're going to multiply by 2, right? And then plus 5. And then 6, it says each term number is multiplied by the next term number minus 3. So you got to do the multiplication first, n times n plus 1, and then subtract 3, right? And then you get these right here. Then the other activity that is also about rules, and you do have very similar to these also on your homework assignment. On your homework assignment, you're going to have to work backwards in there. But basically on this one, they give you, can you write the rule, right? So I give you the term numbers, not like the one before. I give you the term numbers and you need to figure it out. What's the rule? So before, in the previous exercise, in the previous activity, I gave you the wording. You needed to write the rule, and then you can find the term numbers. Here, I'm going to give you the term numbers, and you need to figure out how to find the rule from there. And then what you do is that you're going to find first the constant differences, and then you're writing the term number, which remember is just a position. First, second, third, fourth, fifth, sixth, seventh, eighth, right? You're going to take that number and you're going to multiply by the constant difference, which in this case is 7. That's going to generate some products, right? And then from there, you are going to say, what do you need to do to 7 to get 4? So that means subtract 3. What do you need to do to 14 to get 11? Subtract 3. What do you need to do to 21 to get 18? Subtract 3. So you see that the pattern here is that you're going to subtract 3 to the product. So writing the generic term, you're going to do 7 times n, and then you're going to have minus 3. That's your rule. And then once you find the rule, then you're going to substitute for the 25th term, and you're going to substitute for the 100th term. Right? Now, one that you have on your homework, basically, I give you the terms, and you need to find the rule. And once you find the rule, let's say you want to know what number, what position, what term position is that number in the sequence, right? So let's say that I give you, you don't know the rule yet, so you go figure it out. But I tell you what position is 172. Let's say I work it backwards. I give you what position is 172. So basically, once you do this process and find the rule, you're going to have 7n minus 3 equals to whatever the term number is. The sequence number is 172. And then basically you work backwards. Plus 3, cancel. 7n equals to what? 175. And then, 175. And then you have divided by 7, and that's n equals to 25. So that means that 172 is the 25th position. So this is what you have to do in your homework. You have to work it backwards after you have figured it out the rule. So you still need to go through this process to figure the rule out and then use the rule with the last term number so you'll be able to figure that out. Now this is the more elaborated part on the homework. You can use a table just like we used in the previous activities that you had a table with 16 people in the room. Remember the handshake problem? So you can do a table all the way to whatever I think is 18 or something like that in the homework. You can do the table, and that's something that the elementary kid would do. If you want to make it a little more elaborated, like for your middle schoolers, then you can do this part right here. Okay. Okay. And then again, you're going to show the work, the constant difference, the product of the constant difference times the term position, and then what do you need to do? This should be exactly the same for each one, because all of these are arithmetic sequences. And then once you find the rule, then you can find the 25th rule, 25th term, and 100th term. In this one, and then I do want to point out that not always you're going to have like positive numbers. You can end up with negative numbers, or you can end up with negative products as well. Okay, so for example, right, look at 4. See, the constant difference is -3. So it's -3n plus 80. That can happen. Okay, that can happen, available. And see that 100 term is -220. Yes, it can happen.